All right, hi class. So today we're going to be looking at lesson 1-7. We're going to be looking at more properties. The reason, I don't know why they call this more properties of integer exponents. That gives us no description except that we're doing more integer exponents. So really what we're going to be looking at today is we're going to be looking at how to simplify expressions that with negative exponents and zero exponents. So those are the two main concepts that we're going to be looking at today. So the zero exponent property. Our question is, what is 3 to the power of 0? So let's look at exponent form and then simplified form. We're gonna fill in a table here that will then hopefully help us think about what 3 to the power of 0 actually is. Okay, so let's think about 3 to the power of 4. 3 times 3 is 9, times 3 would be 27, times 3 would be 81. So in simplified form, this is 81. Let's work down in descending order from one consecutive order. So 3 to the power of 3 would be 27. 3 to the power of 2 would be 9. 3 to the power of 1 would be 3. 3 to the power of 0. So this is our question. What would this be? Well, let's look at a pattern here. Math is all about patterns and recognizing patterns. And we can see what 3 to the power of 0 is based off this pattern. So how are we getting from 81 to 27? What operation could we do to get from 81 to 27? We could divide by 3. So to get from 27 to 9, following the same pattern, 27 divided by 3 gives us 9. And 9 divided by 3 gives us 3. So what is 3 divided by 3? 3 divided by 3. What is that equal to? 1. Yes. 3 to the power of 0 is 1. So anything, I don't know why I wrote a 0 there, is 1. Anything raised to the power of 0 is 1. This is called our zero product property. Zero exponent property, meaning 0a to the power of 0, anything to the power of 0 is equal to 1, assuming a is not equal to 0. Okay? So you can go ahead and do these on your own. A is 1. B is 1. C is 1. D is 1. Okay? So go ahead and convince me in the Ed Puzzle video, why is 2 times 7 to the power of 0 equal to 2? All right. So, negative exponent property. So we have 4 to the power of 3 divided by 4 to the power of 5. This is the same as 4 times 4 times 4 over 4 times 4 times 4 times 4 times 4. Okay? 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. So all we have left is nothing on the top, so that is represented by 1 over 4 squared. Okay? Which is 1 over 16. We can actually rewrite this as 4 to the power of 3 minus 5, which is 4 to the power of negative 2. 3 minus 5 is negative 2. 4 to the power of negative 2 is the same as 1 over 4 squared, which is 1 over 16. So you're like, hold up, Mr. Brian, why are you going so fast? What's going on here? How are you getting to negative 2? How do you know that it's going down below? Let's look at this back at our pattern, okay? So back to our table, go back to your notes in the table. Let's continue this pattern. 3 to the power of negative 1, 3 to the power of negative 2, 3 to the power of negative 3. Okay? So we're going to divide by negative 3 still. So we have 1 divided by 3, which is 1/3. The next one, divide by 3. 1/3 divided by 3 is the same as 1/9. And divide the next one by negative, or by 1/3 is going to be 1/27. 1/3 or 1/9 divided by 1/27 is, 1/9 divided by 3 is 1/27. Okay? It's the same as taking 1/3 to the power of 3. Okay? So what that means is if you have a negative exponent, you can send it down to the denominator. So let's say, for example, we have 1/2 to the power of 5. That is the same as 2 to the power of negative 5. Or, here's another example. If we had 6 to the power of 4, that's the same as 1/6 to the power of negative 4. If you send your powers up, it becomes negative. If you send them down, it becomes negative, okay? So if you're sending it up or down, it is taking the opposite, okay? Notice the opposite of 4 is negative 4. The opposite of 5, negative 5 is 5, okay? So it is stating this negative goes down into the denominator. If it was negative down here, you can bring it up to make it positive, okay? So write each expression using positive exponents. So this one's just going to be 8 to the power of 2. This one is going to be 2 to the power of... Actually, no, I take that back. Since this is all over 1, we need to send it down. So it's going to be 1/8 to the power of 2. This one, we are going to send it down because we have a negative exponent. So downstairs, so we have 1/2 to the power of 4. And I might refer to it upstairs, downstairs. That is not technically correct, but it's just a way for us to communicate which direction we're going. Since we have a negative exponent here, we're going to send it downstairs. So it's going to be 1/3 to the power of 5. All right? Write the expression 1/7 to the power of negative 3 with a positive exponent. What that means is we need to send this up because we have our negative exponent. So 1/7 to the power of negative 3 is equal to 7 to the power of 3. Okay? Go ahead and do these two. This one's going to be 5 to the power of 3. And this last one is 2 to the power of 6. Please write down any questions that you may have. Look forward to seeing you on Zoom.